Okay, so today we're going to add and subtract rational expressions. And when we talk about rational expressions, all we're talking about is complicated fractions. Okay, so let's just review. How do you add and subtract just regular fractions? Well, if we have something like 2/3 and we want to add 3/5 to it, remember that you have to have that common denominator. So in order to add and subtract fractions, we've got to have a common denominator. Well, what's the common denominator between 3 and 5? Well, remember, you've got to find their greatest common multiple, which would be 15. So then we want that common denominator to be 15, so then we've got to go make equivalent fractions. Well, how do we turn 2/3 into something over 15? Well, remember, we're going to have to multiply it by 5. And let me do it like this. I'm going to multiply it by 5 over 5. And the reason we multiply, remember we've always said if we do something to the bottom, we have to do the same thing to the top. So that is going to make 15 on the bottom, and 2 times 5 is 10 on the top. So when we multiply this by 5 over 5, remember this is just a form of 1. Anything over itself is always 1. So we're just multiplying it by some form of 1 so that we can get these equivalent fractions. Then we want to multiply this 3/5. We've got to multiply it times 3 over 3 in order to make that denominator 15. So that becomes 9 over 15. So we can change that 2/3 plus 3/5 to become, the 2/3 is now 10/15, and the 3/5 is now 9/15. And then we just add those numerators. So 10 plus 9 is 19, and we do not add the denominators. It stays the same. Remember, the reason we're doing that is we're getting them in the same kind of pie. Like if, there's going to be 15 units in that pie, and so we've got 10 in one and 9 in the other, so how many of those do we have? So it's 19/15. So you add the numerators and keep the denominators. Okay, so we're reviewing that just a little bit because now it's going to get a little bit more complicated. So in this instance, we have got a denominator here of n minus 2. Well, this denominator is also n minus 2, so we already have a common denominator of n minus 2. So then all we have to do is add or subtract the numerators, which in this case we are subtracting. So remember, you've got to pay such close attention to these signs of what you're doing. So I'm subtracting this entire binomial there. So it's like you're saying n minus that 3n minus 1 all over that n minus 2. Well, remember, if you're subtracting a binomial, if you've got that minus sign in front of a binomial, then you've got to distribute that to everything inside there. So it's n minus 3n, and then that changes that to a plus 1 all over that n minus 2. And then all you're going to do is combine like terms. So n minus 3n leaves us with negative 2n plus the 1 all over the n minus 2. And there is your final answer. Okay, so what if we do not have common denominators? Well, we've got to come up with what is the common denominator between 2x squared and 4x. Well, 2 is in a 4, so 4, but then we need that x squared. So it's going to be your largest exponent, but then the multiple of the number. So the common denominator of 4x squared. So we've got to now create equivalent fractions. So let's take the 1 over the 2x squared, and what do we need to multiply that by in order for that denominator to be a 4x squared? Well, that needs to be multiplied by a 2. So we're going to have to multiply 2 times over 2. So 1 times 2 is 2, and 2x squared times 2 gives us that 4x squared. So that is the first one. So now let's take the 5 over the 4x, and what does he need to be multiplied by in order for that denominator to be a 4x squared? Well, it needs another x. So that means I have to also multiply the top times x. So that gives us 5x over the 4x squared. So now we've got these new equivalent fractions with the common denominator, and now we're ready to add them together. So we've got 2 over 4x squared plus 5x over 4x squared. Remember, the denominator stays the same. The numerator, we're saying 2 plus 5x. Well, those are not like terms, so we cannot add them together, but we do go ahead and list them. 5x plus 2. And you know, we just habit of always putting the x terms first. So that's where that comes from. Okay, so they're only going to get a little bit harder. I'm sorry. So now we've got x plus 2 as this denominator and x minus 2 is that denominator. So there's no common multiple of them. So your common denominator is just going to be the 2 multiplied together. X plus 2 times x minus 2. Okay, so we've got, I'm going to write this one a little bit different. We're going to say 3 over the x plus 2. All right, well that term needs that x minus 2. So we're going to multiply it by that x minus 2 over x minus 2. Now we're subtracting that 8 over the x minus 2, and that term needs the x plus 2 over the x plus 2. Okay, so now we're going to make I'm going to multiply these out so that we get these two new terms. So we've got, if I distribute this 3 to the x and the 2, we're going to have 3x minus 6 over that x plus 2, x minus 2. I'm going to subtract, I'm going to distribute this 8 to both of those terms, 8x plus 16 all over that x plus 2, x minus 2. Okay, so remember again, this is a subtraction, which means we have to distribute this negative sign to both of those terms. So 3x minus 6 makes that a negative 8x, negative 16 all over that common denominator of x plus 2, x minus 2. All right, so now we're ready to combine like terms in the numerator. So remember, if you're adding, that denominator stays the same. So we've got a 3x and a negative 8x, means negative 5x, and a negative 6 and a negative 16 makes negative 22. Okay, yeah, I can see that I can't factor anything out of that numerator, so that would be our final answer. Okay, so we're going to just repeat the same process. So this x squared minus 9, remember, that's going to factor into x plus 3, x minus 3. So this term has an x minus 3 in it, but it doesn't have that x plus 3. So here our common denominator is x plus 3, x minus 3. Okay, well this first term, the 8x over that x squared minus 9, factors into x plus 3, x minus 3. So we don't have to do anything with that term because he's already got our common denominator. But this second term needs that x plus 3. So we're going to multiply both numerator and the denominator by that x plus 3. So now we're going to make those common or the equivalent fractions. All right, so remember now, this is x minus 7 times x plus 3. So you're going to have to FOIL that out. And if you do, remember, we're going to multiply this by multiply that, then take that negative 7 and multiply him by everything. Well, I'm going to take a shortcut because I already know what that one's going to be, but you can multiply that out on your own. That's x squared minus 4x minus 21 all over that x plus 3, x minus 3. Okay, so now we're ready to add those numerators. So we made our equivalent fractions. Now we're going to add our numerators in the next step. So we've got the 8x plus the x squared minus the 4x minus the 21. Well, the only terms that you can join is going to be the 8x and the negative 4x. So that is going to give us x squared plus 4x, because we've got a positive 8x minus the 4x gives us a positive 4x minus the 21 all over that x plus 3, x minus 3. Well, anytime I have a term like this x squared plus 4x minus 21, I'm going to factor it and see if there's anything I can reduce. Well, if I factor x squared plus 4x minus 21, I'm going to get, that would be x plus 7, x minus 3. That's the x squared plus 4x minus 21 factored, and that's going to all be over that x plus 3, x minus 3. Well, now we can see that we have got these common terms of x minus 3. Anything over itself is 1, so it's like those get to be reduced to a 1, and so once let me write that in different color, reduce. Our final answer then is x plus 7 over x plus 3. Okay, so number 5, we're going to see, we see that we've got some different kinds of terms here, so I'm just going to see if we can factor anything so that we can come up with what this common denominator is. Well, I see that this x squared plus 4x minus 12, that should factor into, let's see, 6 times 2 is 12, so x plus 6, x minus 2. So we see we've got the common x plus 6, so that gives us a common denominator of x plus 6 times x minus 2. So every term needs to be into x plus 6, x minus 2. Well, lucky for us, this one's already in that way. We just have to do the second one. So we're going to make those equivalent fractions. By taking, let me just start over here, 2x plus 3 over the x plus 6. And that term needs that x minus 2. So we're going to multiply that term by that x minus 2. And then we're subtracting this x squared plus 3. That doesn't factor, but we're going to leave this as factored form, x plus 2, x plus 6, x minus 2. Okay, so we're going to multiply this new term out. And again, remember, you're going to have to FOIL this. You're going to have to multiply that out. That is going to give us 2x times the x is 2x squared. 2x times the negative 2 is negative 4x. 3 times the x is 3x, and 3 times negative 2 is negative 6, all over our common denominator. And that's just that first term. Minus x squared plus 3 over that same denominator. So now we're ready to join like terms. Remember, this is a subtraction, so let's just go in and change all these signs here and then add our like terms together. So we've got 2x squared and a negative x squared, because that's going to make it a plus since we went and changed our signs. That gives us x squared. And we've got our 4x and our 3x here, so that makes negative x. And then our negative 6 and our negative 3 make negative 9, all over x plus 6 times x minus 2. Well, x squared minus x minus 9 does not factor, so this will be our final answer. Okay, so look at number 6 and let's see what our common denominator is going to be here. We have got 5 and a 25. Well, remember, it's got to be the bigger number. If 5 goes into that 25, then 25 will be our the common multiple. We have an x squared here, but we don't have any x's here, so we need that x squared. And then we have a y and a y squared. It always has to be the larger denominator. So that common denominator is going to be 25 x squared y squared. Okay, so let's take our first term, 5x squared over y. Well, what does it need to become 25 x squared y squared? Well, the 5 needs to be multiplied by a 5. We've got the x squared, but we need another y. So that first term is going to have to be multiplied by 5y over 5y. So then we're going to take our second term, and it has the 25. So it doesn't need any of the number, but it does need that x squared, and it already has the y squared, so he's okay on that. We just need to multiply that one by the x squared. Okay, so now let's multiply this thing out. So 3 times 5y gives us 15y all over. Now multiply those denominators. That should give us what our common denominator is, 25 x squared y squared. Then we're going to add. We're going to multiply out these two terms. 6x times x squared gives us 6x cubed all over 25 x squared y squared. Okay, so now we've got a common denominator. We've made our equivalent fractions. Now we're going to add our numerators, and we don't have like terms, so we're going to have to just list them separately. So 15y plus 6x cubed all over 25 x squared y squared. Okay, only have to write that denominator the one time. I see I could factor out a 3 in the numerator, but that doesn't really help me. I can't factor out a 3 in the denominator, so that would not be able to reduce, so therefore that would be your final answer.